Hi everyone, my name's Alfred. I work at Matrix Labs. I'm the in Labs. And how many of you know what Matrix Labs is? Just to get a feel for it. It's weird not having anybody physically like here or that I could hear you. So typing in the chat, that would be great. Otherwise, I'm just talking to my face, which is a little weird. Okay, whatever. So Matrix Labs, we're a hardware AI like development platform. We make these development boards. This one's called the Matrix Creator, and it goes right on a Raspberry Pi. So I'm not sure how many of you know what a Raspberry Pi is, but I'll just assume that you don't. And if you do, then you'll know what I'm talking about. So a Raspberry Pi is basically a little credit card size computer. That's all it is, really. It runs Linux. I think it can run a version of Windows. It's like a very light version of Windows. It runs on ARM. But yeah, so it runs Linux. You can has HDMI. You can plug it into a screen. This is the power. This is the processor. This is like Wi-Fi. Has USB ports, an Ethernet port, an audio jack, GPIOs, so a bunch of pins that we can do in and then a micro SD card slot. So that's what a Raspberry Pi is. And by itself, it's just like a computer. Like you can run programs on it, you could run a server on it, you can do anything really you can do on whatever computer you're on right now, albeit this is way less powerful. I would hope, unless you're on like a little, I don't know, Android tablet or something. So yeah, this is a Raspberry Pi. So by itself, like it can just do computer things. What we've done is we've made this board here, Matrix Creator. And I'll post in the chat the link to our website so you can check it out there. And essentially, oh, nope, I'm good. So the Matrix Creator has all these pins here, and it goes right onto the pins of the Raspberry Pi, right? And press it down like a sandwich, but you can't eat it. So the Matrix Creator has like a bunch of sensors on it. So it has an accelerometer, a gyroscope, a magnetometer. So that all gives you like directional measurement, like acceleration, its place in space. Where else? Accelerometer, gyroscope, magnetometer. It has IR, so for TVs, UV, so the sun, humidity, pressure. It has an array of 8 microphones. So if I take it off, so you see each of these little bronze rectangles around the outside. Their input is on this side, and there's 8, and those are all the microphones, and there's 8 of them. So with that, you can do interesting things like run Amazon Alexa or Google Assistant, or do some sort of like processing algorithms, like Fourier transforms or whatever, in order to like process audio and do interesting things with it. There's also like open source, like privacy focused voice services that like don't send all your data to Amazon and Google. And those run on device. So those run on the Pi, do all the processing on this. You know, it's a pretty basic, not super powerful computer. So it's really impressive, and it's super privacy focused. So the Creator also has NFC. So, you know, like the payment stuff that you do with your phone, or let me see, I have one here. NFC tags. So you could like tap it right here and do something with it. It has Zigbee and Z-Wave, so a lot of the like smart home devices that don't use Wi-Fi use these protocols called Zigbee and Z-Wave, which are sort of like Wi-Fi but not the same. They're specifically made for like smart home appliances and stuff. So this can connect to all of those like directly. And then it also has a microcontroller, so an ARM Cortex M3 microcontroller. And then on the back, it has a Xilinx Spartan 6 FPGA. So I don't know if there's any like computer engineering students here. If you are, you probably know what that is, or maybe not yet. But basically it's a chip that instead of like all the wires being like set how they are, you're able to programmatically change all the wires inside of it. Don't ask me how. I don't exactly know how. I have the high level view of it. But it's really interesting. You can do really interesting things with it. You can like optimize things like Bitcoin mining, for example, uses an ASIC, which is like a specially made hardware. You could, with an FPGA, make sort of an ASIC in order to do Bitcoin mining. Of course, based off of how Bitcoin is, it would take too long at this point, but 6 years ago, you would have been able to. So that is the Matrix Creator. So what we're going to do today is I'm basically just going to go through the Matrix Creator. I mean, if you have any ideas or suggestions or questions, please say it in the chat. I'm like looking right at the chat here. But I'm going to show you how easy it is to program it, how you go connecting to a Raspberry Pi even, how you, and it's pretty simple. I mean, it looks daunting if you've never done it before. But at least with our documentation, we have really good documentation, so it's all need be able to do it. So yeah, so first step is you need a micro SD card right here. So I pulled it out of this slot. So I flashed this already on my computer. I used a program called Etcher. I went to the raspberrypi.org website and downloaded their operating and I flashed it onto this card. So that's done. Just for the sake of time, I'm not going to show you how to set up Wi-Fi on it. Instead, I have a really long Ethernet cord that I routed from my router. So it'll just be connected via Ethernet, and then I'll plug it into power. So that's just with the micro SD, well, the micro USB slot. And now it's turning on. So that'll take it like a minute to turn on. What's the recommended size of the card? So we typically use like 32 gigabyte micro SD cards. You'll like never really run out of space unless you're doing things with media, like I don't know, making a Plex server or something. Yeah, the 32 gigs is good. It's like $10. It's not too bad. But you could probably do it with, but we always use 32. Yeah. Good question. Thank you. So let me see here. I'm going to share my screen. Okay, nice. You can see my screen. Sweet. I'm going to quit Finder. Go away, Finder. Okay, so this is my screen. So now, oh, and I don't have the chat open. Here, let me put the chat on another screen so that I can keep the chat visible. Perfect. Okay, so here is my screen, right? So what we want to do, first of all, we have to look for the Raspberry Pi on the network. So in order to do that, I'm on Mac. On Windows, it's different, but since I'm on Mac, I'm just going to show you the Mac way. I don't know how many of you are on Windows versus Mac. I don't think I so I'm on Windows right now. But there's ways on Windows, and we have guides. If you go to docs.matrix.1, like here, I'll go to it. Better than saying the link than me going to it. So docs.matrix.1, we're using a matrix creator. So device setup, matrix creator. Oh, look. Ooh, a beautiful GIF. Don't we all love GIFs? So ecosystem overview, we're going to be using matrix light. So, quick question for, well, I'm going to be programming this, like when we get to the programming of this, all in JavaScript. I'm not sure what you guys know. I would imagine most of you, if you know programming, it's leans towards Java or Python. Please in the chat type what programming languages you know. Java? Yeah, yeah. Also, like what year are you guys in? And what's like your major? Junior? Cool. Beginner in Python. Okay. Ooh, nice. Oh, so Charles, you probably know about FPGAs. Yeah, yes, VHDL. Oh, fun. Don't ask me to explain VHDL. Cool. So I'm going to show it to you in JavaScript. I mean, JavaScript's really easy for you to understand. There isn't too much syntax weirdness, and I just know JavaScript best, so you guys will be able to get the gist. But we also have like documentation in Python, and Go and Ruby is like meh. So like you can see all of the stuff here. It's very well documented, but I'm going to be doing it in JavaScript because that's just easiest for me. Okay, cool. So we're scanning the network for the Raspberry Pi. It's already connected to Ethernet. So my network, but you're not in my network, so this is okay. So this is the Raspberry Pi. I know because I don't have any other random Raspberry Pis on here, although I do have other Raspberry Pis, but this one's been flashed and I changed the host name of it. That's the Raspberry Pi. Then I'm going to bring up my terminal. So, you know, on Windows, it's console, although Windows does have the Linux subsystem, so then you can go into like a Linux terminal, and the Mac terminal here is most similar to like a Linux terminal. So we're going to SSH into the connecting our computer via secure shell in order to get to the terminal of this computer, the Raspberry Pi. So SSH Pi, which is the username, at that IP. Oh wait, yeah. Connection to host. Oh no, I forgot. Okay. Would it be possible to? Oh yes, I am so sorry. I didn't notice. Thank you so much. There we go. Okay, so I forgot one little tiny kind of important thing. Raspberry Pi, like the SSH thing, it's not really a secure way of connecting to the Pi. I mean, if you're wanting to do secure things, so by default it's disabled. So I need to enable it. So let's go. Gotta connect it back to my computer. Let's see if it shows up. I don't want to have to open up Linux. Give me a second. Sorry. Come on, Finder. My poor computer. It's like 5 years old with a hard drive. I need to replace the hard drive. But it's an iMac, so and it's one of the ones where the screen is glued on, so it's I don't want to do it. It's gonna take me a day. Yeah. Come on. Oh my god. I'm sorry that this is taking long. Dang, I can't believe I forgot this part. I've done this so many times. Okay, I mean, if you guys have any other questions in the meantime, so like I was saying, in order to program it, so the reason why you would use like a board like the Matrix Creator is because, like, if you want to use, oh, here we go. If you want to use a Raspberry Pi, come on, hurry up. Okay. Wait, this is the boot. Does it go in the boot? Let me see. I don't think it goes in the boot file. Give me 1 second, guys. Raspberry Pi setup, SSH. You know, let's see if this works. If not, it'll take 2 seconds to get back to this step. Okay. So the reason why you'd use a board like the Matrix Creator with the Raspberry Pi is because if you want to do anything more with the Raspberry Pi other than like basic programming and a server or whatever, you would want to add things to those GPIOs. That's why the GPIOs are there. It adds so much more functionality to the board. So normally, if you want to do that, you need to have like wires everywhere. You need to go through a bunch of forums and stuff in order to like figure out how to program it and get it set up. And you know, you can do that. I've done that a bunch of times. It's possible, but if you're just beginning to learn, or if you just want to do things quickly, it's kind of a hassle. And so, you know, the point of us building the Matrix Creator was so that you have a bunch of things in one place, and then we made super, super easy to program. Let's see if it shows back up on the network. So that's the idea of the Matrix Creator. Let me see if it's back on here. It looks like it's back. Yes, wait. Okay, yes, so I've connected to this Pi already, so I have to go, Mac. Why? No. G. Okay. No host. Delete. Save. Bye. Okay. Okay, so we're in business. So yes. So here's the Raspberry Pi terminal. So the password for Raspberry Pi's default is Raspberry. So I'm going to type Raspberry. And now we're in. And it clears, so it's a little prettier. More, and this can be full screen. Okay, so we're in the Raspberry Pi, finally. Now we're going to go to our documentation. Let me the documentation. Oh, come on. Let's put that there. Let's put that there. Okay, so this is documentation. We're going to use Matrix Lite. So we have like 3 library layers. I'm not going to go explaining all of them, but Matrix Lite is like our most modern one for like, what is it, Charles? Yeah, this computer engineer student. So, you know, we have a C++ layer. And by the way, all of our like Verilog code for the FPGA is open source. So if you want to go through that, feel free. You can modify it if you have the device. All of our code in general is on GitHub and open source. So, you know, we're very about open source, and just, you know, if anybody wants to see it, go for it. So going into the JavaScript reference. So wait, getting started, JavaScript setup. There we go. Okay, so now we take a little bit. So we're copying this command, so we're going to install node.js, which is basically a library in order to like use JavaScript. I don't know, how many of you have used Node before by any chance? I mean, you said you were Python, Java people, so I'm not sure. Yeah, they typically don't teach you JavaScript in school, which is a shame, because it's such a popular language. Okay, so that's done. Let's go install npm. So this is like a package manager for Node. And then we're going to install npm Matrix Lite. So this is going by pretty quick. That's good. Ooh, make sure you have installed Matrix How before continuing. I didn't read my own documentation. That's the problem when you don't read it. So this isn't going to work once this is done. Well, I hope the install will work, but you know, if I try running this code, it won't. So remember, read the documentation. Yeah, I'm gonna have some coffee. Let's see. Okay, cool. Error. Failed to install. Huh. Okay. I'll ignore this. Oh, there's a lot of errors. I'll ignore this for now and let me go install how. So Matrix how, I'll explain. It's the hardware abstraction layer. It's the library layer that I was talking about earlier that runs that you can program in C++. So let me go over here, copy. So think of our library layers like a cake. Like first is like the VHDL code. So running on the FPGA. With that handles, the FPGA handles all the connections of all the pins on the Raspberry Pi to all of the sensors on here. Plus it does the, what was it? What's it called? It basically handles like microphone data and for the microphones and converts that to the sends it to the Pi. Please don't take a while. So yeah, that's the matrix how. That's the Verilog layer. Then from there is the matrix how. So that's running in C++, and that's communicating. That's setting up the communications with the Raspberry Pi and the FPGA, and then you're able to like program it. And by the way, all of our C++ code is documented, which is even rarer to find in C++. So if you know C++, you'll appreciate that. And then above that is Matrix Lite. So Matrix Lite communicates with Matrix how communicates with the FPGA in Verilog. Lots of layers, it's a cake. Have like several languages that you can program from. JavaScript, Python, Go, Ruby-ish. Yeah. If anybody has questions, I take questions continuously. How is it working for Matrix? Okay. So, I mean, it's really fun. Like, we're a very small company. We're like 5 people now. The CEO, CTO, like our chief like AI hardware guy, which he's amazing. Like, wow. Another hardware guy, and then me. 5 people. So really small team. It's deaf startup culture. Like. You just have to get. There's not stuff. You can't like load off something to somebody else. It's all on you, and you have to like figure out things. So it's very fun. With COVID and everything, we're not getting to go to events and do interesting things like that. But well, we're doing this. This is fun, albeit early Saturday morning. So I mean, yeah, it's a lot of fun. It is a lot of fun. We're growing. We're right now raising like a 750K seed round. So with that, we'll be able to hire more people. We just got admitted into this like really big 5G open innovation lab in Seattle. So like the sponsors of that lab are like Microsoft and Intel and T-Mobile. So they're like making connection. It's a really cool thing. Not many company, like I don't know how many applicants they got for that, but we were lucky to be admitted. So it's fun. I mean, very startup culture. And by the way, for you, Labs is based out of Miami. Like and the rest of the team, well, our CTO is up in Portland, and our hardware guy, me and the CTO and the CEO are here, and then our office is here. So yeah, although has kind of become the office at this point. I have like all of our devices here, like for shipping and stuff, just so I don't have to go anywhere. Wow, this is taking a while. So yeah, it's really fun. It's super startup-y. Yeah, it's exciting though. I like it. I've been with Matrix Labs since Matrix Labs was created. I'm like founding team, which was like, what, 4 years ago? 5 years ago? 5 years ago. Yeah. Yeah, 2015. Yeah. And Matrix Labs was incubated out of this like bigger company called AdMobilize. Where's the office? So the office is in Miami Beach. So actually it was in Miami Beach. We kind of got rid of our office and literally moved a bunch of my apartment. So like that's from the office. All these bins here from the office. There's like bins with like 40 Raspberry Pis in there. So yeah, things calm down and we're able, yeah, lol. And it's like safe for like everybody to go into the office. Like, you know, some people like live with their parents, and whatever. So, you know, high risk people. So we can't have them, um, chances, we have to be safe. So once we get an office again, probably, hopefully in the next 6 months, we'll see, fingers crossed, we'll probably be in Wynwood. Yeah, yeah, because everything's happening in Wynwood. It's fun to be there. Um, yeah, and the beach is like crazy expensive. You don't even want to know. It hurts me to think about it. Um, yeah. Yep. Any other questions while we're waiting for apt-get update and upgrade, which is basically just updating the packages on the Pi? I woke up a little late and sorry, but I think we're having fun. I hope so. I can't tell. The wonder of virtual things. Just curious, what has been your most proud or cool project you've worked on? Ooh, that's a fun question. Most proud or cool project? Uh, so I guess two. Proud. I wouldn't finish it. Let me go get it. I am wearing pants, in case you were wondering. This drone. So, so this was a drone I was making like 4 years ago, with the Matrix Creator. So a Matrix Creator would go right here and a Raspberry Pi here, and the idea would be to have the Matrix Creator like running as the flight controller for this, with its IMU like handling all of the motion. Um, just some advice. Making your own flight controller from scratch is very difficult, especially if you're trying to do it on an FPGA. So, yeah, be warned. This is why they sell kits where you can board for like $15 to do it. So this was a really cool one. And then another one, let me see. I have a box down here with one I'm most proud of is this robot arm. Ta-da! And what this does is let me get this thing. It basically, oh no, okay, whatever. There's like a lamp that it picks up, and it looks like the Pixar lamp. So it'll like, it starts here, it'll go down here, pick up a lamp, the claw will like close. Oh, you guys can't really see. There we go. The claw will close, and then it'll move up, and then turn, and it'll look like the Pixar lamp. So this is like company related. Oh, this is done. Let me take advantage and not waste time with the downloads. So this is like company related project that I've made. Personal project that I've made. Ooh, now we can reboot. Okay. Let's see if this works once I reboot. Is this. I don't know how many of you guys like EDM and specifically know this DJ called Rez. But I like them. So this is like their glasses, and it's turned on. So yeah, it's cool. It has a little potentiometer here, so I can I programmed it to change the brightness of the LEDs. You can see here it has like an ESP8266, some buttons, oh, and a logic level converter. So this is like a little personal project that I've been working on. I just leave it turned on because it looks cool. Come on, restart. Restart. There you go. Okay. To your question. Raspberry Pi. Oh no, it's not Raspberry Pi, it's Raspberry. Come on. Raspberry. Okay, so we're done with the house setup. Ooh. Let's see if I can go back to JavaScript, getting started in JavaScript setup. I'm gonna do this last one and see if that works. No. Questions. Cool. How much would you say that drone or ARM costs to build? So the ARM costs. So the matrix creator costs like $100. Then the Pi is like 35, 10. So electronics wise, it's maybe like $200 in electronics. And then the ARM itself, it was like a $30 kit without the servos. And then we had to buy these beefy servos, which are like these metal servos are like 20 kilogram servos. Like if you get your between them, it is not going to be pretty. At least it's going to hurt a lot. It might draw blood. It's thirsty. So it was probably like $400, $300 for the robot arm. For the drone, I don't remember. It's been years. Maybe similar. Maybe like $300. Yeah, because the motors are expensive and the electronic speed controllers, the ESCs, are expensive. Yeah, about that. Why is it error? I'm gonna see if it works. Install node git rebuild. Huh. Okay. Okay, let's just see if this works. And then if it doesn't, we're in the Pi, right? I went into the light.js library, so I did just change directory, change directory light.js back when I was in the other one. And then now we're gonna do sudo nano index.js. So this is empty right now. I'm going to copy this code, which now so you can see it, copy, and paste. Nice. Okay. So let's see if this works. Control X, Y, enter. And then node index.js. And it didn't work. Why? Find module. Okay, so it didn't do it right. Okay, let me go over here. Let me just redo all these commands really quick. Yeah. Yep. Already installed. Okay. So then this done, npm init y. Okay, cd light.js npm init y. That's fine. And then this. Okay. Hope this works. So if and when this works, that looks like the same error. Error, make failed. The node module event, blah, 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 blah. Rebuild, no description, repo, that's fine. Install node git rebuild. Let's just do what it says. The install script is probably not a problem with npm. This is likely additional logging output above. Wow, okay. That's so useful. Fatal error. No such file or directory. Ooh. I thought this was installed. That's why. There we go. Okay. CD. Oops, not DB. So light dot dot dot. So let's go to how over here. Let's see what happened here. So this did that, that, yeah. Okay. Matrix header files are installed there. The compiled matrix how library is installed in there. Okay. That should be fine then. Let me see if how works. Okay, so touch app dot cpp sudo nano. Oh no, why am I no? Oops, did the wrong thing. App. There we go. Okay. This is code. It's basically going to make this turn into a rainbow that rotates. I'm not going to explain the how code right now. I just want to test this to see if this works. So command below using okay. Why? What? Matrix file, no such file or directory. Everloop.h. Did it install how properly? Seems like it didn't. Yeah, that's what it seems like. Let me see. Okay, so some packages couldn't be installed, blah, 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 an impossible situation, or if you're using an unstable distribution. Dependencies depends on that, not installable. You have held broken packages. Why? You know, I am just going to hardware debug. Yeah, it's not a joke. This isn't even hardware at this point. This is all in the software. It's not even communicating with the matrix creator yet. Yeah. I think the problem is that I installed like the big like the desktop version of Raspberry Pi OS, and that never goes well. So I have an SD card here that's already flashed with everything. I'm just going to go into that one and hope it works. Okay. Yeah, hardware debugging is no joke. Yeah. Oh god, and this isn't even like actual hardware issues. That's a nightmare. Yeah. Yeah, sorry. This was supposed to be like easy. I'm failing at showing you it's easy. This is fun, huh? Yeah. I mean, I'm having fun. This is kind of annoying. Yeah, you know, whenever you're doing things with programming, there's always issues. It never goes the way you want it to go. That's the lesson here. You never expect it to go right. Especially on a live demo. Okay, good. So that's running. No. Yeah, yeah. Going here. Okay. Oh, me. Are you sure? Yes. Okay, so SSHing into this one. Does this one have stuff? Wait, this is empty? Why is this empty? Why? Okay. Time to go for a third SD card. So over here, I might as well just boot this up. I'm gonna do that. Yeah. So here's another cool project I made. Third time's the charm. So this is a matrix voice. It's smaller. It doesn't have all the sensors, but it has like 8 microphones. And the white squares, by the way, I didn't explain it. These are LEDs, lights. It has a more powerful. This has a more powerful FPGA. This has like a ESP32 on it, which is like a Bluetooth Wi-Fi microcontroller module. So this can run by itself without a Pi. But in this case, I have it running with a Pi and with a little relay here. And this is used to use voice control to control your lights in your house. So like this goes to a light switch, a light panel. This would go behind it, like through this little hole, and it would control your lights. It's really cool. So I'm gonna boot this thing up. Yeah, I'm gonna boot this thing up. Okay, cool. So many things. Let's see. This ends at 11, right? I have time. Yeah, hopefully. Crossed. So forget this. Put that over there. This has Wi-Fi already set up. So if you want to see it, I'll put it like right there. Hope you can't read my sticky notes. So let's see over here. My favorite Jolly Rancher flavor. My girlfriend asked me that last night, and I couldn't answer her. And I still don't have. I don't know. I got this pack that is like different flavors than normal. So this has lemon, mountain berry, strawberry, pineapple, and orange. From this pack, I'm between lemon and orange. It's weird. Like it actually tastes like the orange one actually tastes like you have an orange in your mouth. It's not like the fake orange taste that things normally have. It actually tastes like an orange. Wild. You pick orange, yeah. I mean, I normally love orange, yeah. Here, I'll have an orange one for you, Charles. Yeah, I saw it in the store yesterday, and I was like, I'm an adult. I'm gonna buy candy. I'm gonna do whatever the hell I want. So let me not have it on the phone. Okay, so let's see here. Yeah, it really tastes like orange. It's amazing. Yeah, sour gummy worms are so good. Okay, so this one is called Hallway Light Switch because I literally had it as the light switch in my hallway. And I keep doing this. So SSH, Pi app, yes, Raspberry. Okay, cool. So this one, see, it has less things in it, but these things like work. Hopefully. Where was it? I think it's Raspy. So on this board, on the Raspberry Pi, we have this voice service running. I shouldn't have eaten this. Now I sound weird. We have this voice service running called Raspy, and it's open source. It runs on, and you can program it to. Actually has like a local web interface so that you can set up like, oh, I want it to listen for like turn on the lights. and it'll like do that. And then you can programmatically set it up to turn on, well, the relay. So let me go into here. So CD WebSocket, ls, CD matrix, ls, ls, CD node, CD backup. Okay, yeah, this should be it. So if I do node index, oh no. Oh, well, I mean, that could have worked, but whatever. Okay, hopefully, so you see how there's a little red light on here? Turn off the light. It didn't hear me. Raspy. Oh no, it's not Raspy. Porcupine. Turn. So here it says, oh, the on the light. I always forget what's the command. I think maybe it's lights on. Raspy. Raspy. It's not Raspy. It's Porcupine. Turn the light on. Yay! The red light's no longer there. And then light has been turned on. Raspy. Turn the lights off. Ta-da! I don't know if you heard the click, but that's the click from the relay. So I'll explain what a relay is. It's basically like an electromagnet in here. And it flips a switch from like one side to the other with the electromagnet. And that's how a little 5-volt connection here can control 100. Because, yeah. And it's a bunch of cool stuff. So it works. We finally got something working. I'm going to just like go back a bunch. Actually, let's just go over here. So I'm gonna make like a new file in here. Yeah, or this is how, blah, blah, blah. Okay, so I'm gonna make an index file. So, yeah, nano index.js. I'm gonna copy this. So this is the thing that makes a rainbow. It like has the matrix light library, so that's adding it as like a constants required. So it's letting everloop. It's basically an array of length of the amount of LEDs. So you can basically like what is the length of the LEDs. So this one has like 18 LEDs, whereas this one has 35. So based off of what board you have on top of it, it will just do it. You don't have to hard code how many LEDs. So let LED everloop. So if it's 35, okay, this part you have to hard code, but if it's 35, like adjust it to be this, else this. And then I'm not going to go over the math, but it's like a bunch of sine waves in order to like get the colors moving, the R, G, and the B to be modulating throughout the whole thing. That's basically what it is. And then this in order to like slowly show. Tick, 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 tick. It's like Minecraft. Okay, so X, Y, enter, not ls, node index.js. And then now, a rainbow! It works! I should have done this from the beginning. Whatever. Ta-da! So, yeah. I'm thinking. So let me just ask you guys, like, what do you guys want me to do? Would you like me to like put a matrix creator on here and then I can like do some console.logs of the like sensors on it, like the UV or the gyroscope and stuff like that. You guys want to see that, and just so that you can see the documentation? Yeah. Okay. Cool. So I'll do that. I have a screwdriver here somewhere. I have so many things. This desk is a mess. Yeah. Oh, something also I should do. Do you guys know about the website hackster.io? Have you heard of it? Anybody? It's a website. Have not. So it's a website where it's like the biggest like hardware dev community on the web. Yeah, it's cool, and people like post their projects on there. It's like really cool. So let me open it. So we're like friends into their office a bunch of times. And you can see here like people posting really cool projects. So like for example, your projects that you're doing during the hackathon, if you want, you could like post it on here with like the instructions of how to do it. And then people can see it. It's cool. So we have a page on here, Hackster. And here we where, so like setting up Amazon Alexa or Google Assistant or Raspberry, doing like direction of arrival on the voice. So here, like they're moving a cup on the table and it's making like a little sound. And then with the 8 microphones surrounding the Matrix voice, it's able to like show you, if we programmed it for the LEDs to show you like where the sound is coming from. So really cool things. We have a bunch of projects on here that you can see. We even did like a virtual like a month. And these are like some of the winners of that hackathon. A voice-controlled 3D printer. This scared the heck out of me. I have a 3D printer, and I sure as heck wouldn't want it voice-controlled. That seems like a fire hazard. Did it, and it won. So yeah. Yeah, so let me get this thing. I'll try to like speed it up a little bit. Oh no, there's only 6 minutes. I don't know, Ari. If you guys want, I can go. I have a virtual, like an expo booth. I'm not sure. I can check if I do. I can be on there afterwards if any of you guys want to talk, and we can like actually talk. I think I can add you to like speak. Yeah. Let's see here. Okay. This up. I'm gonna do this blazing fast. I'm not gonna explain too much just because I want you to see. You normally use JavaScript to create these user project. It depends very much on user and project. If I'm making a project, I'll always go for JavaScript. Like I away with the light. So that's literally this thing. So I'll always use JavaScript, but you don't have to use JavaScript. Yeah, that's basically it. There aren't really, it's very rare where a specific project, like you need to use a specific language for it, and it's not your preference, because most things you can program in multiple languages. Yeah, so this is like all the code for that. So let me go over here. Raspberry. Come on, go faster. So I'm gonna go over here. I don't need the JavaScript setup. JavaScript reference. So I'm gonna need this. CD light.js, node index. Oh no, not node index. You know what? I'm gonna make a new one. Node taco.js. Node, it's nano. I'm going fast and I'm typing things wrong. Okay. Add that, so require that, and then, so to get the IMU data, So we add the library on here, and now we're getting IMU data. It's 2 lines, and then console.log. Honestly, I can just like put this like copy. I don't even need to do anything else. And that should work unless I messed up on something, which is possible. What did I do wrong? Oh, there's a... See, I messed up on something. There we go. Next one, enter. There you go. It doesn't, I didn't make a loop, but that's the IMU data for that instance. Yeah. Yeah, let me remember how the heck to make it loop around. While. Let's see if this var data equals that. And then output over here, data. Let's see if this works. Oh, okay. Well, yeah, I'm not going to go looking. I haven't programmed in a few months, so I forgot. Yeah, I mean, if you guys have questions, feel free to let me know. I have like a minute left, so... Yes, that's exactly what I wanted to use to control a drone. The issue was that, like, it was us trying to run it PGA, and then I tried doing it on the Pi, but because the Pi is running like I had a latency of like 40 milliseconds between each pole of the IMU. The drone needs like sub 20 milliseconds in order to be like, you know, reasonably fly. So yeah, it never flew. I mean, it did lift up into the air, which is why it is missing the legs over here, and it crashed. But it never reasonably hovered or anything. Yeah. It's 11. So, I mean, I can also stay here. I don't know. You're welcome. Thank you guys for attending. I hope you liked it. I'm gonna see if I can go to the expo and talk there if you want to talk more. If not, I'll just put my email on here if you guys want to email me. And yeah, you can feel free to email me. It was fun. Cool. Hope you liked it. Hope you got something out of it. See ya.